Alright, I will start a new file and I will go through previous setup of the script really quickly. I will build it from scratch, but I will go through it very quickly. And then we will look at how we can solve the questions from Susan. So I will first of all make a new script, new document here in Grasshopper. I will also make create a new file. So we really start from nothing. Okay, in the previous videos we just created a box. This time I make it a bit more elaborate, and because it can be any geometry, and in that case actually it's better to have a proper model of your room, and let's do that. So we actually create a model with a real wall and everything. I will keep it simple though. That's pretty okay, I think. Now we can build our script. So this is our model for now, and now we start building our script. I go through very quick. Put here the bifocals so you can see what I'm doing. Butterfly. We need the butterfly geometry. Create butterfly geometry, and here we can just place here B-wrap. By the way, as soon as you put it in here, this will translate it to a mesh. Oh, sorry, this is actually the wrong tool. This is what we need here. They all always need a name. For the inflow and outflow, I just add surfaces because we only have surfaces here. This is the inflow and outflow. Don't forget to change the name. Now I'll just set a very quick custom preview. I use the B-wrap wireframe. This actually helps a lot to just hide the whole object. Gonna take all this here and hide it. I'll turn off the preview here, and no, that's actually not what I want to do. I'll just put this here, and now I can add a material. I don't really care about the material itself. I'll just add a transparency. Oh, I forgot the indoor wall. You can always add stuff with here manage B-wrap collection. You can add things, so just select and then add. Now this is also in your Rhino B-wrap container. So these are already defined. Now we need to let Butterfly know what these elements are. They have a name, but they also need to be defined, and this we do with the boundary condition. So we have inlet boundary. This is here actually the inlet boundary. We can define a temperature 18. And for the velocity, we need to define a vector. I'm gonna cheat here a bit. I just add here a curve, and this is the direction of the curve. I add a curve container, place this in here, and that is the velocity. That means the direction is this direction, and then the length of that, which is currently 0.3 meter, will be the velocity per meter per second. So 0.3 meter per second. Of course, there are more elegant ways to do that, definitely. That's all we need really now for the model. So for the velocity, we define the curve, which defines the speed and the direction, and then we define the temperature, which is in Celsius. And then we have the outflow. The outflow we also need to define, which is outlet boundary. Put this in here. I will not change anything here for the sake of simplicity. And we have the wall boundary. We also need to define the wall. Okay, all solid objects basically. Need a toggle. Okay, I can place this here, and let's see. Oh yeah, we need a name as well. Sorry, call this advanced. Now we have a case. Now we create the mesh, the block mesh. Put the case here. We can run that. Oh yeah, and we need to write this to the computer. Now we have a case. We have the block mesh. We create a plot mesh. I will not show you how that looks like now. You can see that in the previous videos. Now we can create the snappy hex mesh. Again, these are all things I already showed several times. Here at the global refinement level, I I would double check here so the mesh is properly built. It's something I'm gonna check because you should see that. You can load, we can put here the case in this tool, load mesh, so we can see the mesh, what was created. And we need a toggle again. You can see this is how currently the mesh looks like. This is not really very useful. So there's a big problem here. That's why we need to use the refinement levels here. There's refinement levels. If we put this here and say, for example, 2 and 2, which is represents the minimum and maximum, then it creates a much more detailed mesh. And in that case, I would go even further. Now there's something else we need to check. If we can refine the edge here, the corners. We can do that with the butterfly snappy hex mesh dictionary. So that, again, I would more call this settings, really. And here under the option snap, we'll put here false. It's not 100% on the, it's a bit, yeah, it doesn't snap 100%, but it makes the corner really crisp. So we have this mesh here. We don't have to show it, we can always turn it off. Now we would need to have the solution. Yeah, butterfly solution, you can find it here. We need a recipe. We're gonna use the heat transfer recipe, which calculates heat and velocity and pressure, depending on what kind of field we were testing. Put this in here. I leave all the settings as they are, just for the sake of simplicity. We need some solution parameters, although they're not shown here as mandatory, but we need it in order to set the probes. We need the control dictionary here, butterfly control dictionary, that defines how, here we can set an end time. End time means how many iterations. I think 1,000 is fine, we leave that. That defines that we're gonna run this 1,000 times. Otherwise it would just run and continue. And we need probes, butterfly probes. For now we don't use the additional parameters. For this we need points, fields, and right interval. Well, we can set the right interval, but we don't. Now points would be a plane inside which defines the probe points. And we could do this by just using this, the ladybug generate point from point grid. So now I have you can see my plane outline here. We need to set a grid size. This is in meter, so 0.25 is good. So every 25 centimeter we have a grid point, and these are my points, and they can move in here. And I need to define fields. So fields would be a panel, T for temperature and U for velocity. I need to press here the multi-line data, so it's clearly two different fields. That creates a mesh. So that creates points, but also a mesh. So that looks all good. Now we set here, we take these toggles here and not running it yet. Place this here. I'm not running it yet, but soon. And now we can add butterfly load probe values, and we're setting a field as we did before. The field is basically what item we want to test, and this needs to be set to one value. Now it goes red because there's nothing in there yet, and we just copy this, so we have a second field which represents the speed, the velocity. Now if we run this, it starts to calculate already. So that looks good, it all runs. This also looks good. Now we can can look at the vectors if we want. So in that case we want vectors for the velocity. Can just go here and display the vector display x, ex. Put here the starting point, which is my points here. I'm gonna set the relay. I love relays. It's nothing more than just extending like a cable. Maybe we do put this here. These are my points, and these are the values of my vectors. So the vector can go in here. And now we already can see the vectors. Now I could add here a multiplier, so I can control the size of the vector a bit better. Maybe that's okay. and I don't want to see my points. That's why. So I'm gonna turn this off, and we can see already how the air moves around. Now, if we want to look at the temperature, we can make a heat map here, ladybug heat map. We could put here the values and then the mesh. Here it's always good to set a maximum minimum. That helps quite a lot. Parameters. One more thing, just to make sure you understand, the output here, the temperature is in Kelvin, so we need to change that. We need to actually go here and say minus 273.15. I could also set here a range to determine the minimum and maximum. It's probably good to do. The bound I can use here just to see what is the minimum and maximum. That helps me to set the minimum and maximum for the okay, so the maximum is 25, and then this minus 1 e plus 300 is a crazy number. It's because of we have points inside here, which is exactly the problem, right? So we want to get rid of these points inside. Yeah. So how can we deal with this? This is the question from Susan, right? So one of the questions. 25 is the maximum, so we can set here the maximum is 25. It gives us a bit of a better understanding. Well, the problem now is we have it's all good. We have we know the air movement. Maybe what we can also do here is moving the mesh, because it's kind of overlapping with the vectors. Move geometry, and then we just say c vector -1. No, that's too much. Sorry. 0. Okay, don't want to have this preview on, and that goes here. Now it's not overlapping. But we have the problem that we have a very small number representing this wall. It just doesn't understand this here. And now it's not very representative. For the vectors it's okay, because the vectors somehow kind of almost explain that there's a wall. It understands there's a wall. There's still points in here. Don't be fooled. These vectors just so small you can't see them, but they are still here. So how can we deal with this? But maybe let's answer the first question. So now we have actually something inside. We set a wall inside. Setting it like this seems like it works. Well, we could add another object. Let's try and add another object. That's maybe a table. I'm trying to make it overlap on purpose. Let's see how that works. And we do the same. We add it to we add this thing here. Now, of course, it's going to recalculate. If I would have only a box, only a hull outside, you would run into problem. But overlapping boxes actually works. Now, if we want to calculate, if we want to get rid of the points inside here, then this becomes all a bit more difficult. So I will show you the way. If you have B-wraps now, what can we do? So if your model is a mesh model, then you can use the mesh inclusion option, or so you can use this one. And for the B-wrap, you can use the point in B-wrap. So these are very similar, really. So we'll have a look. I'm gonna make another relay. The relay goes into here. This is my B-wrap, and then I need to check the points. So how that all works is I have my point system here. This is my points, this is my surface, these are the points, and this creates the probes. And this is the field. So let's get rid of all this here. This goes here. Now that works in a way that we check now what's inside the B-wraps. We have now this thing here. This is overlapping. We have the wall inside. We have all these we have the walls, the roof, and the floor. They're all kind of not overlapping, but they are touching each other. And we have another object at the end. And they are all in here. Five B-wraps. And then we add the points here, and that creates a list of false and true. False means it's not inside, and true is inside. Now how can we now remove? So what you need to keep in mind is now that we are removing probe points from this mesh object, or from this point grid. Later on we also need to remove the mesh faces which are attached to these points, because the mesh created here has the same amount of faces as points on the grid. That's how it works. because we need to match the values. They need to have exact the same values as the mesh has faces. So see here, values are 814 and the mesh has 814 faces. You can see that actually here. So we have a list where it says either inside or outside. False means they are outside the B-reps, and true means inside. So first of all, we can dispatch a list. So we have a list of points, the original list of points. Oh, sorry, this is absolutely wrong. The pattern goes here. This is the pattern of true and false, 0 and 1, yes or no. This goes in here. And the list of points which we want to check against it is this one. So we have 27 points which are inside B-reps, and then the rest is outside. So these are my points. Now that created already a problem. But I can also hide this now. I want to hide this as well. I only want to show these points, and see, there is a problem already. That tool actually doesn't work, and we're gonna see that the same problem actually with the mesh. The problem is that this only can test always just one B-rep. In that case, it checks here. It excludes all the points, but then here it doesn't. There's actually another tool here. It says point in B reps, two different things. Put this in here, and then now it works. So we can place here the points. We can place the list here, and now both of these areas are excluded, right? So we can see which points which we still have and which are excluded. Also very important, now points for the vectors, the starting point for the vectors we also need to change now, because we still using the old ones, but we actually need to use these ones here, these points. We need to change that in order to reflect the correct points. Now it works. But now the problem is we lost the mesh, because now the values are less. We only have 762 values, and the mesh has still 814 faces. In order to remove the faces from the mesh, we use this tool here, cull faces, mesh, and then the pattern, same pattern. Now we have a mesh which has 762 faces. So now if we put this in here, now it's correct again. Oh, sorry, I forgot something. Let's also set the temperature for the walls, because this is quite important. Let's set something here so we can see some difference. Otherwise we have just the temperature moving through with always the same value. Now we have 30 as a maximum. Let's say 35 is the maximum. And oh yes, we also want to move this, of course, again, so it's below the vectors. Actually, I want to turn the vectors off just for a bit. I just want to fix this here. 26, and the outer temperature is now slowly getting there. The maximum is 26. That looks much more promising. Just to recap, we used the B-reps here and placed them in here and said, can you measure if my point is inside any of these B-reps? Meaning all like the walls, these objects inside, and if yes, please exclude them and remove the correlating faces from the mesh as well. But the problem is that our mesh, the snappy hex mesh, is not as exact, slightly off, as you have seen before. If we turn this on here, you actually see that it's not 100%. We could again go here maybe and say snap to true. Then our mesh would be created here in the snappy hex mesh tool is much closer to the original B-reps. But it doesn't capture it 100%. So you would need then to increase the global refinement level. Now imagine your object here, all these objects here are actually meshes. So let's try to solve that problem. If it's meshes, then there are again other ways to do it. Meshes. So if this is all mesh from surface, so I take this here. I'm gonna add this here so I can create meshes. So now I have 5 meshes in here. So this is my walls outside, this is the objects inside, and so on. Now that's going to be more difficult. I have 5 meshes. If I place this in here, I'm going to end up with the same problem as before. I'm going to delete this. This creates a list. Now if I place this in here, oh no, sorry, this is my pattern. place the list of points here, and then this is my pattern. If I now look at the points, it somehow trimmed off this area, but it didn't trim off this here. That was the problem. What could I do instead? What we could try is to combine these. Also didn't work really. And it's because it's all overlapping. So now we have one mesh, but we have one mesh object, but inside there's still several meshes and they are overlapping. The test plane here is actually not overlapping with the walls. So we could try to get rid of the walls first and then create the mesh. Let's try that again. So we can use the set here, explode tree. We need to craft the tree. Let's see what's in here. Okay, we don't need this. We don't need this. We don't need this one. We need this one and this one. So let's recap. We have all the mesh objects. We identify the objects which are actually which are intersecting with the plane. In here we need to craft the tree, because otherwise we can't select an object. If you want to do it like this, there's other ways to do it. You could have like a list object here and select. I like to do it like this way. It's quite convenient. Then we need to flatten the mesh. You need to flatten the mesh so you can actually join the mesh later on. And then this now is one mesh object where I can measure if a point is inside that mesh or not. Although I have two boxes in here, they are both one mesh object. And then it's the same procedure as before. Then I have my mesh inclusion list pattern. The pattern goes in here. The original points go in here. I dispatch the point. I use this point for creating my vector start points, but I also use then the pattern from here to fix my mesh later on. And let's rerun this whole thing and let's see how it works, if it works. Oh yeah, I want to turn off these points here. They're quite annoying. And also these objects. And what I want to do is here, I want to increase the vector, make this whole thing a bit faster. 1,000, yay! Just a few adjustments here. Just try to change the refinement level for the walls. And let's see if that helps to resolve this a bit. Not really. And I'm almost thinking if we are already so high with the refinement level, we could also turn this to true, and maybe that is actually better. It looks a bit better, I would say. So, okay, Susan, thanks for the question. It's super, it really pushes the boundary, I would say. If you have a very complicated model with loads of different parts and they all overlap and so on, I would really try to create B-reps out of it. And you can do that afterwards. You can do that before you do the exclusion calculation. That means it doesn't interfere with the rest of your script. So if that is the case, I would really take the mesh from here. In case these are meshes, these are all meshes, I would turn them into B-reps first. And then do the whole exclusion stuff in here. That only calculates it once on that side. It should not interfere with the script itself, because the snappy hex mesh is completely separated from that. So you have your meshes in here, you calculate your block mesh, your snappy hex mesh, and then all the rest doesn't interfere with what you do with your meshes in here. I hope it makes sense. Alright, that was actually not that simple. I ran into quite a lot of issues during the recording, a lot of unexpected problems, but I think we got to hopefully a good result, and you can use it. You can use all the stuff in your projects. Again, Aswin Indraprastha. I really hope I'm pronouncing it correct. Thank you for joining. Thanks for the support, and hope you see you around. If you have any questions, just text me. All right, see you in the next videos.